Welcome to class number 11. In this class we will discuss about what is dynamic routing and what are the types of different dynamic routing protocols and the concept of administrative distance. So let's look into this topology. So here we have three locations. So let's say this is office A, office, let's say office B, and office C. So we have users everywhere in each office. Okay, so I'm just representing one PC here, but yeah, there are like multiple PCs and multiple users on each office location. Now we want to establish the connectivity between all these three offices. So as we learned from the previous classes, we can do static routing. So for suppose we have 10.0.0.1 here, this PC, and we have this PC here, 01/24. Here we have 172.16.0.1/24. Okay, so if PC1, let's say we can say PC1, PC2, PC3. So if PC1 wants to communicate with PC3, we need to have the routing static routes on all these routers, because the router sitting in office A does not know anything about the network of office C, right? This 192.168 network. So we need to tell each router in the path how to forward the packet towards PC3. Same we need to do in the return direction. For the replay traffic also, we need to tell each router until this point that where 10 network is. For suppose if we want to establish the communication between PC1 and PC3, so for the original ping request, we need to, for suppose PC1 is connected to this router, we need to add a static route here stating that to forward any packet towards this network, we need to send it to next hop, which is here. So there is static route 1 here. Then once the packet comes here, then you need to add another static route here. Then once comes here, you should add similar static route here. Then one more here, one more here. Let's say it is connected to here. So you need to add 5 static routes on different routers. So this is only for the ping request. For the ping replay, you need to do the same thing. So if you have 2 or 3 routers, it is easy to implement static routing because you only have 2 to 3 routers to update. But similar to this topology or bigger topologies, it is not easy to manage the routing with the static routes. So it will be very difficult. So these many static routes we need to add just for the communication for one network in office A to another network in office C. But in each office you will have multiple networks. So for each network you need to do the same thing if you want to go with static routing. So this is configuration headache, and there will be some other issues as well that we will discuss in the next slides. So in this type of topology, instead of using static routing, we can use dynamic routing. What dynamic routing is? In dynamic routing also we need to do some configurations on all the routers, but that's just one time task. Once you establish the dynamic routing initially, if you are going to add a new network here, it will be automatically advertised to all the routers in the network. So you don't need to manually update any routes. It will happen dynamically. Okay, so you will learn about dynamic routing in the next coming classes. But for now, just to remember that in dynamic routing, the routing updates will happen automatically. So let's discuss why we need to choose dynamic routing. So first thing is scalability. So as we discussed previously, so for suppose you have the office setup, office A, office B and office C, and you have everything in place. For suppose if you want to add, if you are going to add a new network, so you are adding 1/24 network. So in static routing case, you need to update all the routes, right? But if you have a dynamic routing, once you add it here, if the dynamic routing is already established on all the routers, it will be automatically advertised to the all routers, so you don't need to do anything. So maybe one or two commands just over here, so that will make sure the route is propagated all over the network in different offices. So scalability, so when the company network is growing to scalable, static routing is not an option. The company must choose dynamic routing. Similarly, for suppose there is a network in office C, for some reason they want to remove that network, this office no longer need that network. In static routing case, if you want to remove the network, you need to remove the static routes as well, because you don't want to put static routes which are not in use, right? So even when you try to remove a network, it's not easy with static routing, because you need to update multiple routers. But in the dynamic routing, once you remove the route here, it will be automatically removed from the rest of the network, so it will happen dynamically. And another scenario, for suppose in office B there is a /24 network, but after deploying this /24 you wanted to change it to /23 because of the requirement. So in static routing case, you need to go and update all the static routes wherever you have mentioned this /24, and you should change it to /23. Okay, but if you have dynamic routing enabled, once you change it in this location, it will be automatically propagated to all other locations. You don't need to do anything. So for scalability wise, we will choose dynamic routing for the complex topologies, to add routes easily, to remove routes easily, to modify routes easily. So this will resolve any scalability issues with the static routing. So let's see another scenario. For suppose PC1, PC3. So PC1 can reach PC3 in two ways. One is this route, another is this route. Okay, for suppose with static routing you want to choose this route. Okay, so in static routing, what we tell on this router, to send any packet to PC3, send it to here. So you will say the same things like that here, right? But this link went down for some reason, so the packets will come here until static route here, and it will drop here because there is no connectivity here. There is some issue with this physical link. So with static routing, this router will not aware of the downside of the down part of this network, right? But in dynamic routing, what will happen is, if this network goes down, this router will advertise all other routers in the network stating that okay, this route is not available anymore. So this down event will be updated to this router, so that router automatically uses this route to reach PC3. So in case of static routing, if someone notifies that this network is down, you have to go manually and update the static route to here. But this is not possible in real time, because the physical links may go down at any time, right? So there will be no administrator readily to perform these changes. By that time, all the packets going through this link will be lost. So that will be downtime. So for redundancy, it's better to use dynamic routing protocol, because it will automatically adjust the routing, because whenever a link goes down in the network, the routers will advertise that this network is no longer available via this route, and so that the other routers in the network will choose the alternative path. So next scenario, so we have PC1 and PC3. So there are two paths. Okay, for suppose you have here 100 PCs, here you have 100 PCs. So these 100 PCs trying to communicate with all these 100 PCs. So let's say there is 100 pings going on. So with static routing, either you can point this way or this way. There is no option that you can point it to both sides. But in the dynamic routing, they will support dynamic load balancing. So what happens is, it will send 50 packets this way, they will go this way, and another 50 packets will go this way, so that you can fully utilize both links to send the traffic for the load balancing scenario. This is not we can do with the static routing, because with the static routing you are just choosing one route statically, so there is no load balancing happening in the static routing. So the another reason, so we will discuss the advanced topics in a different class, but to support any of the advanced features like dynamic VPNs or overlays like MPLS or anything, static routing will not work. These type of traffic engineering only works with the dynamic routing protocols. Okay. So let's see what are different types of dynamic routing protocols available. So let's see, the first topic we are discussing, that routing. So routing is based on the IP, just to move packets from one network to different network with the use of routing routers. So routers can know about the routing route information in three ways. One is connected route. Connected route is nothing but if we define an IP on router interface, it is a connected route, because whenever you configure an IP on the router, it will understand that that network is connected to that particular interface. So that is connected route. And the next type of route we can configure on a router is static route. Static route is administrator manually configure the IP route command and the destination network and where it should send next hop. So another way is dynamic routing. So in dynamic routing we can classify into like three sections based on the type of routing. So one is distance vector. Distance vector is, for suppose if there is a router here, router here, router here, here, so there is a PC. So if in distance vector routing protocol, this router will choose the path in this way, because there is only one router in the next hop. Okay, so this is distance vector, because if it goes on the other side, it has to cross two routers, so this will be a longer route. So distance vector is similar to this. So in distance vector we have three protocols. One is RIP, RIP, IGRP, EIGRP. RIP is routing information protocol. It's a old protocol, no one uses it now in the production. And IGRP is also old protocol, internet gateway routing protocol, and this is enhanced interior gateway routing protocol. Okay, so this is the enhanced version of it. Okay, these two also will not be used much, but yeah, still some companies will use it. These are Cisco proprietary, means it will only run on Cisco devices only. Okay, and next one is link state. In link state what happens is every router will know about the entire network topology. Okay, so and once they know the entire network topology, they will use some algorithm to find out the shortest path. So that is the type in the link state protocols. So we have two in this category. One is OSPF, another one is ISIS. OSPF is open shortest path first. So this is mostly used routing protocol inside organization. So if you have offices and data centers, internally you will run this protocol to route packets within your network. Okay, and another one is path vector. So in this you can define which path the packets needs to take. There will be like more control and more settings available. So in this the major one is BGP, border gateway protocol. In this there is two variations, IBGP and EBGP. So we will discuss what is the difference between these two in the next classes, but for now recognize that there are like two categories in this, IBGP and EBGP. Next, So we know that most of the networking concepts are standards. That means any network device has to follow that standards. So in all of these dynamic routing protocols and everything, so these two only proprietary, means they will only work on specific vendor equipment. So these two will only work on Cisco equipment only. If you want to run it on Arista, FortiGate or Palo Alto, any other, it won't support it, because these two were invented and used by only Cisco company only and their products. Okay, rest of them are all standards. So any device supporting BGP means they have to follow the respected RFC. RFC is nothing but standards defined for that particular protocol. So which routing protocols will most use? So OSPF will be used mostly for the internal routing. Internal routing means whatever the private IPs you have inside your network, you will use this protocol to provide routing information for all the offices and data center locations. For internet or with extranet connections with different companies, you will try to use BGP. So in this we have two flavors. So this is internal BGP, this is external BGP. So internal BGP also can be used to route the packets, but yeah, there are some differences when we use iBGP and eBGP. Yeah, let's not worry about them now, but BGP will be used to mainly for the internet or extranet, and OSPF will be used for the intranet. So we know that internet is nothing but group of routers interconnected each other over the world, and they are capable of routing packets with public IP only. Okay, so in this case they need to also exchange routers. So in this case you have like thousands of routers on the internet, they are exchanging public IP routing information. So they all use BGP, especially eBGP. Okay, so the routing protocol that you can see on internet is BGP. So now let's discuss the concept of administrative distance. So let's look at this topology. So we have, let's say this is R1, R2, R3, R4, R5. So there is a network connected to R5, which is 10.0.0/24. So let's say R5 and R4 has dynamic routing enabled. In this case they are using OSPF. So R5 will advertise this route to R4 with the OSPF protocol. R4 learns it, and then we have OSPF between R4 and R2, and it will provide that route information to R2, and R2 will do the same thing. So with this OSPF, R1 learns that to reach 10.0.0/24 it needs to forward the packet to R2. So this is the information it got from the OSPF protocol. So when R4 learns the route from OSPF from R5, it also has another routing connection to R3, which is using BGP. So R4 will advertise the same route to R3 but on BGP. R3 also have BGP running with R1, so it will also advertise the same route to R1. Now R1 is learning that 10.0.0/24 should be forwarded to R3 based on the BGP information. So a router can have multiple routing protocols at the same time. So in this case it is receiving the information about same network. So when it receives a packet with the destination IP falling in with this in range, which one it should use? It should prefer OSPF route or BGP route. So for that there is a concept called administrative distance. So each route will have some value of administrative distance. So the value of administrative distance can range from 0 to 255. So each route, whether it's coming from the OSPF, BGP, static or connected, each will have unique AD value. So the router will choose the lowest one. Okay. So in this case, let's say it is eBGP, it is 20 AD value, and this one is, let's say, 110. So it will choose this route because the AD value associated with this route is 20, and for this one is 110. So it will choose the BGP route. Okay. So basically administrative distance helps with when a router learns the same route from different sources. Like in this case, it's one is coming from OSPF, another is coming from eBGP. So it will choose the lowest route which has lowest AD value route. So in this case it will be eBGP. So the packets will forwarded in this direction. So let's see what are all the administrative distance for different routing sources. So connected routes is 0. Okay. So when a router has an IP configured on its interface, it will add that into the routing table as a connected route. So if you learn the same route from any different routing protocol, it won't add it to the routing table. It will just ignore that update because it already knows that it is directly connected on that particular interface. The next one preferred is static routing, when administrator manually configure the IP route. Okay. Then we have distance vector, link state and path vector, and these are all the administrative distance values for each routing protocol. Okay. Each one is different, as you can see. So there is another routing protocol called EGP. So don't confuse with eBGP. eBGP is different and EGP is different. EGP is prior to BGP. Prior to BGP, it was used to advertise the public IP or information between the ASs. Okay, so this is not used anymore. So this is the older one. So but don't confuse with EGP with eBGP. eBGP is different. Okay. And next, what is if route is added with 255 as the AD? So the special purpose of 255 is when you configure, when a router receives a route with this AD value, it will not add it into the routing table because the 255 means the source route is unknown. For suppose if you want to black hole some traffic, or if you don't want to forward the packets for this particular network, you can put 255 so that it will just ignore, it won't add that route into the routing table and it won't know anything. Okay. So then default so these are all the default AD values. In some cases we can tweak these values, so that is the advanced topic, but you can just remember that all these values are default AD values. Some of them we can change, depends on the topology and scenario. Okay. So for 255, just want to add a correction. So when you add a route with, for suppose you added a route with 255 value of AD, it won't be added to the routing table. Okay. So router does not know anything to do with those packets because it's not in the routing table. So this is just the order I just want to mention. Like this is like most preferred route this way, and less preferred route this way based on the AD value. So AD value is increasing this way. Okay. So there is no particular lab for this topic. So all you need to is just remember the default AD values for at least the most used protocols. Okay. That's all for this class. In the next class we will discuss about OSPF.